So earlier we talked about framework and component. Now we kind of talk a little bit about the current trend. So we did mention about cyber physical systems, IoT, cloud computing, cognitive computing, cloud computing, cognitive computing as a part of Industrial 4.0. So in the outcome of this digitalization, there's four things that we could actually remember: instrumented, interconnected, inclusiveness, and intelligent. So instrumented is basically your instruments could be connected, and the interconnectivity is where instruments, equipments can connect to each other. Inclusive is actually you can include different equipment into one, and then it's intelligent to tell us about it. So this is four ingredients that brings the Industrial 4.0 together. So instrumented data surrounding us, devised by human generated data that includes the systems and the components. Data also getting quicker and faster to generate, so that they speed up the cheats, and also of course able to analyze things faster. Interconnected devices are also interconnected, like smartphone or your Google Home or Amazon Google, right? Those are interconnected. This is also a platform to help us process information, like Watson IoT. The platform provides a place to receive data, translate into a common format, so that the computing brain can work. So it is important and agreed to the standard such that ISO 26000 could actually continue to talk in the same language. So this is a part of a program which if you are interested, can look a little bit more about the Watson IBM program. Inclusiveness is an example of the alarm clock that can include in like a weather, so that it include other information, so that when this other information is added together, this could be a way to actually make the product more interesting, at the same time more easier to ingest data. So it becomes a new revenue stream, whether they can form a partnership leveraging from that. So this is kind of inclusiveness. And intelligence, so intelligence basically making some information and the degrees of informed decision. A lot of time is through machine learning, artificial intelligence, some predictive analytics, and cognitive computers as we learn the data, where is it created from. There is a number of sensors being conducted around the world. So with that, how does the industrial framework works? So Industrial 4.0 frameworks works in a way that's goods and services. So it goes through three different processes: design, make, and use. So it's pretty easy to remember. So design is basically you consider the change of idea of ownership. Now you no longer need to own a car, but you design an idea that you can still able to move from one place to the other place. Things like Grab or Tada or maybe Gojek or BlueSG, right? They simply rent out, or you can actually ask people to fetch you. So you're no longer concerned about owning the vehicle, but you actually think of the services itself. So it's a simple way to leverage and perceive change. So this is part one, design. So design on how the product can be used today, you inform on the design of the future. You have insights of product design is coming the way how you use today. So like Michelin tire, they connect their data of tires so that they can have a better fleet understand where are the drivers going to, how to save fuels, and then it gives a new service and products. So this is design. The second part is make. How do you make? Of course, once you design, you need to make it. And then once you make it, is basically important tools in a system. So basically you make the things happening, and then when you start to make, you ask questions and how can you make things faster. So some of the example here is like tire manufacturer Michelin. They connect their data so that they can make things to the way that they can keep the product new and services. So yeah, with today sensors and analytics, right, the context of external data becomes well spread. So after you design, make, then you need to use it, right? So using it becomes way of a product itself. So you design, make, and use. As a result, you become more familiar with the things, and then sparing some of the laborious stuff. So usage becomes important. So things like wearable sensors make it possible to monitor the vehicle surrounding or the worker surrounding, preventing over excessive fall in terms of different hazards. So three parts: design, make, and use. So now this is kind of a summary ingredients of Industrial 4.0: interconnected, inclusiveness, and intelligence. So instrumented is about data, interconnected is about connectivity, inclusiveness is about content, and intelligence is about decision making. So Industrial 4.0 component is characterized by information extensive transformation of manufacturing in other industries, especially for building industry. It's just a possible of 5 years or to 10 years slower compared to the car manufacturing industries. So a connected environment of data, process, peoples are in terms of the internet enabled industries to be able to leverage an information that is means to be realizing the ecosystems of innovation and collaboration. So 4.0 could take several advantages: CPS, cyber physical security, system, industrial internet of things, or IIoT, machine communication, M2M, machine to machine, so that machine can talk to each other through some cloud computing. Of course, we will talk a little bit of, learn a little bit of augmented reality and simulation, digital twin, 3D printing, autonomous robotics, some ERP, business intelligence, and big data and big science. So this is a small part of Industrial 4.0. List is not exhaustive. It can be as much as possible. So the broader visions of clear referencing of architecture, mainly from characteristics of physical industrial work, can be in terms of cyber physical security. It's a very core process, and transfer of autonomy to autonomous decision. So physical cybersecurity could be combined with intelligent physical component so that it can make sense of it. So it's bridging the digital with the physical side in the industrial context, right? So with that, in terms of physical security, the physics or physical and the software component has to be intertwined, so they can kind of give us a way to look at things differently. Yeah. So another characteristics of CPS is that is the next revolution in terms of engineering, essential dimension to bridge the digital and physical. So it really thanks to the information technology and operation technology. So that CPS, cyber physical systems could actually communicate to each other, uniquely identify what to do and when to do through some protocols. So CPS can also have controller, sensors, and actuator. That's what we actually have a look on. So it's a building block. So a CPS is basically a building block of 4.0. In addition, is able for us to track, move, and remote control things. So with that, this IIoT also describes the things across various industries such as logistics, gas, and ranges of consumers that the smart home solution as per track is no longer a sense, it's no longer far away, right? It's sensitive or sensor equipment can live out the way that we live, so that assets such as robots, some of the facilities could actually be enhanced. And IoT is also known as industrial internet. Is actually coined by GE in late 2012. It brings brilliant machine together, and it works in a magnitude of industry. So it helps to build things faster, stronger, and a better decision. So Internet of Things or Industrial Internet of Things holds a great potential quality control, sustainability, and green practices. It also consists of assets that is able to sense, communicate itself through either public or data infrastructure, analytics and information and through humans itself. So IoT is also a piece of hardware that communicate between platform and on-prem services. So this data shows a little bit about our sensors, some gateway or edge gateway, and then we have a platform or is an on-prem premises server, and then this gives us data analysis and application among automated processes itself. Okay, M2M communications is about communication between exchanges between different technical systems. So machine can then now talk to machines itself.